Saxon Algebra 1 half lesson 88. Welcome, my students. Today we're going to deal with geometry. We're going to talk about surface area, which we have already talked about. Surface area of a right solid. I almost didn't write this part because it just seems confusing. But then I remembered, actually, I want you to see this phrase and not fear it. Solid, it means it's three-dimensional, okay? So it's a physical shape that we're familiar with, and the ones we've been dealing with up till now have been circular cylinders, which is like a oatmeal container, right? It's a circle on the bottom and the top, and then it's straight up and down. And that's what this means, that it has straight sides. Perfectly straight. Everything meets in, all the corners meet perfectly evenly. It's not tipped or crooked. It's just a straight, perfect cylinder. And that's good news. That makes it easier for us to do the calculations. Okay, so when you see this expression about the right solid, be happy, don't be sad. Okay, we already know the basic gist of finding the surface area. That is our magical wrapping paper. That's what I want you to think about when you see surface area. We're trying to find the area of all the different outside dimensions, right? It's perfect. It's magical wrapping paper because it doesn't need to overlap at all. But we want to cover all the outside edges of the creation. So today what we're going to do is talk about it in other shapes besides just the circular cylinder that we have already discussed. The first shape is one of my favorites. Did you guys ever eat Toblerone candy? It used to always come in a triangular shaped package. One of my daughters told me that, knowing that I always use this as an example, is like, uh-oh, Mom, Toblerone changed their packaging, which makes me want to cry. But in any case, it's a triangular box. That's what I want you to imagine. John gives us a picture that looks like this and asks us to find the surface area of the right triangular solid, triangular. Dimensions are shown in meters. Okay, I'll only need that at the end. Okay, our process is exactly the same. We get out box cutters and we start trimming this. We cut off this end and that end. We know there must be a triangle down there too, right? So here's the top. If you can imagine this as the top, we'll stand it on its end. And that's the bottom. Pretend they're exactly the same. Then with this triangular tube that I could pick up and look through, what we're gonna do is we're gonna flatten it out. Thank goodness it's made out of magical cardboard that lies perfectly flat. And it would have folds in it, right? From where it used to be folded up like a triangle. But we unfolded it, so there it is. So that's the sides. Okay, let's go through. We'll deal with each of them. These are the easiest because they're exactly the same. So what we need to do is we need to find the area of this triangle. The area of a triangle. If you don't know this formula by heart by now, you need to stop what you're doing and memorize it immediately. And I'm serious. No more just like hoping you think of it. You need to have this one burned in your brain. Base times height divided by 2. In our case, the base is 3. The height is 4. It's divided by 2. But we also want to multiply it by 2 because we have 2 of them, right? That's the easiest way to do it because then what we see is that the total for the 2 triangles is 12. Right? I could have divided it by 2 and said, okay, it's 6 for each triangle, then added them back together and gotten 12. That works too. This is just my shortcutty way of being able to just cancel the 2 triangles and the divided by 2 that's in the equation. Okay, so we've dealt with the triangles. We know it's a total area of 12 meters squared for both of them. Now, this side thing, here's what we have to remember. This top edge used to be wrapped around this triangle, right? So that means these dimensions depending on where we cut it. Let's pretend we cut it right there and we're laying it down. So this would be 4, and this would be 3, and this would be 5, and this edge would be 16. Does that make sense? So again, we use the perimeter of the top shape to help us find the long edge of the lateral. This is called the lateral, or the sides. Okay, it's an, whoops, side. That's what this section is called. The top, the bottom, and the lateral sides, same difference, okay? So now we can do this. The area of a rectangle is the length times the width. We'll call this the length, so we have to add these together. That looks like 12 times 16. All right, let's do that. You do it, I'll do it, and we'll compare answers. Don't look. I'll count to 20 and give you time to finish. Okay, I got 192. Some problems ask for the total surface area. Some problems will ask for the lateral surface area. If this problem wanted the lateral surface area, it would be 192. But this problem asks for the total surface area, so it's 204 meters squared. Surface area is always a squared dimension because it's the area of the outside. Even though it's a three-dimensional object, it's not the third power because we're not measuring the volume or what would fit inside. We're just measuring the outside areas and adding them all together. Okay, that's the right answer. We have one more example. This was a triangular right solid, and now we're going to do what I like to call, in technical terms, a wonky right solid. It's a shape that looks like this. They're fun to draw, you guys. If you're into it, just go ahead and start. You don't necessarily have to draw them. I'm drawing them now just so you can be on the same page with me. I mean, literally, you can understand what we're looking at because I assume you don't have your book in front of you. But if it helps you get into it, when you're doing your homework, just do it. It's fine. Okay, this is kind of like a mailbox tipped down its side, an old school mailbox, right? That would have the little handle here and this would pull down. That's one way of looking at it. Some students, you know, middle school boys, think it looks like a toilet and like the seat would lift up there. Yeah, I can see that too. But in any case, this is our shape. It doesn't have a fancy name. We just call it a right solid. And in this example, we're asked to find just the lateral surface area. So that tells us we don't need the top and we don't need the bottom. We just want this in-between part. All right, and John also gives us very, very helpfully, and he does this in most of the problems now. This is a diagram of the base. It says find the lateral surface area of a right solid 10 feet tall, so we can add the 10 right there. It's 10 feet tall, and whose base is the figure shown on the left. And that's what I'm in the middle of drawing. Dimensions are in feet. Okay, so this is what John tells us. 2 right angles there, 8 and 8, and then he does this. Okay, what I hope you recognize by now is that he's saying, oh, there's a semicircle attached right here whose radius is 3, and 8 represents the straight part. My diagram isn't as precise as it might be, but it's straight until you get to the radius of the circle, and then it's curvy, all right? Now, what we want to do then is we want to cut this open. I'm going to cut it right there. this cardboard, let's say we cut it on this edge, there's going to be one bend. I like to show the bends. It helps me orient myself. There's going to be one bend right there, and then this part down here at the end is all of this. Like all of this is all of this, right? Okay, so the question is, how much is this part? Well, we look down here, that would be this on our diagram, right? We cut it here, cut it there, and so this corner corresponds to this corner. We want to know this section because that will be the first section on our flat piece. All right, it's not 8, and we can't guess just by looking at it. What we have to do is we have to use this information about the radius. And remember that if the radius is from the center to the edge is 3, then that means this dotty section is 3, and that dotty section is 3. Those are radii also. So this must be 6. So now we can put a 6 on this section. And now this whole bendy part is going to be this 8 plus this 8 plus the circumference of this semicircle. Okay. So I'm going to work over here. The area, no, not the area, the circumference of the semicircle. Let's see, there's 2 ways you can remember that. You can remember it as pi times the diameter divided by 2, or you can remember it as pi times 2 times the radius divided by 2, and then that reminds you there's actually a third way. It's just pi times the radius. This is my favorite because I would always rather do less work than more work. So I know I want to add pi times the radius, which is 3. All right, let's find out what is pi times the radius. 3.14 times 3. I'll give you 10 seconds to do this with me. $9.42. So it's going to be 6, and we're adding all of this. 6 plus 8 plus 8 plus 9.42. That is the dimension of this. So we can add that all together. Oh boy, what do we have here? 8 and 8 is 16. Plus 6 more is 22. And then 9 is 31, so it's 31.42 is this whole side. All right, and we're trying to find the area of this. So the area, I didn't mean to write the whole word out, sorry. The area of the whole rectangle is length times width. The length, we can call the longer side the length. It's 31.42 times the up and down, because that would be this, right? This would be 10 times 10. Oh gosh, thank you, John. I love you when you make it easy. Slide the decimal 1, right? So it's 314.2 feet squared. And that's the right answer, yay! So, this lesson is taking something we already know how to do, find the surface area of cylinders, circular cylinders, and it's just expanding it to some different shapes, but the process, the thinking process is exactly the same. We just have to deal with some different shapes. This is a really good time to make sure all of these formulas are locked into your brain. So I'm just going to do a quick review of the formulas you need to have. You need to know the area of a triangle is base times height divided by 2. You need to know that the area of a rectangle is length times width. You need to know that the area of a circle equals pi r squared. Makes sense? Circumference of a circle is pi. I prefer this. Sorry, I forgot the 2. I prefer pi 2r for that formula. What else did we use in this lesson? I think that's everything that we used. Surface area doesn't really yield a formula very well. You just have to find the surface area of anything. You add the area of all the surfaces. Remember? Well, maybe you're in the process of learning this, but my teachers used to always say you can't define a word by using the word itself. Well, I just did that. But hopefully it makes sense. And then the lateral surface area means the side of the object only, not top and bottom. All right, make sure these are all committed to memory, locked in. I could wake you up out of a sound sleep and you would scream them out loud without a moment's hesitation. All right, that is the end of our lesson 88. I will see you on the video chats. Goodbye.